All right, so we have one more question in this section. So this one is definitely a little weirder. We have r equals sine 2 theta. None of our formulas involved a 2 theta. We just have tangent of theta or cosine theta and sine theta. So the sine 2 theta we need to change out using our formulas. So sine 2 theta is the same as 2 sine theta cosine theta. All right, now here it gets a little uglier. So for sine theta and cosine theta, like I don't have much, but I can take my x equals and y equals, and I'm gonna divide both of them by r. So I know cosine theta is x over r, and I know sine theta is y over r. So I'm gonna put those in place of the theta parts. All right, so I have to learn how to write smaller. So we have r equals 2xy over r squared. I'm going to go ahead and multiply by the r squared, so it's all of my r's are in one place. So now we have r cubed equals 2xy. Not much we can do with this. So this is going to be, we're going to take our Pythagorean equation and square root both sides. So r is the same as the square root of x squared plus y squared, but because it was r cubed, we have that square root cubed equals 2xy. So that is horribly ugly, but there are no more r's and there are no more thetas, so I have done what I have been asked. So you technically can, for any polar equation, just wherever there's a theta, shoehorn in one of these. Wherever there's an r, put in the square root of x squared plus y squared, make it do. Okay. So the other thing we have from this section is a whole bunch of these tables that are about the different types of graphs you can have in polar. So we haven't looked at too many, but our graph of r equals a number is a circle. If I have r equals 2a cosine theta, where a is positive, they have the 2a because it's half of that number in front of cosine is the radius of the circle you're going to draw, but the circle you draw, instead of being centered at the origin, it gets pushed over on, for cosine, the x-axis, or we see on the next one, the y-axis, which they call the line theta equals pi over 2. And the polar axis is the positive x-axis. So yeah. Then we start getting some crazier looking graphs. So there are cardioid because they look like hearts. They, actually come to a point. And then we have limicons. I think that's how you say it. Without an inner loop, this is sometimes it's referred to as a dimple. And then there's the ones with the inner loop. And whether it's a sine or a cosine, and how big or small the a's and b's are, like determine which of these graphs we would get. and what the orientation would be. So we can actually get like 4 different orientations. Like you could flip it vertically, or basically like you could rotate it 90 degrees through all the different interpretations by changing out sine and cosine, or changing positive to negative. Yeah, because we get a whole lot of crazy looking polar graphs. And we get the really pretty one. So lemon skates involve squares. So r squared equals a squared, some number squared, cosine of 2 theta, or sine of 2 theta. Then over here, back to r equals a sine 3 theta. So this 3 here, it turns out if you put a 5, you get a 5 petal rose. If you put a 7, you get a 7 petal rose. Over here on the even numbers, just due to the way it works, you put sine 2 theta and you get 4 petals. If you put sine 4 theta, you get 8 petals. So it doubles the number of petals when it's an even number in front of the theta. If it's odd, though, we just get the singles. It's just kind of a weird way the way it works out. So yeah, in trig classes past, like they would actually give you the equations. You had to remember which graph it was to like work through what the shape was going to be. And it's just a whole lot of wasted time because you really don't use these that much. And when you do, like you have the equation, and the first thing you do is like mess around with the equation and figure out where the bounds are. So we're going to do one of those in the next section. But the next section spends a whole lot of time on these. And I've just kind of copied the charts over. Your web work homework on this is, here's an equation, which graph matches? And it's going to be typically these. And the 4 graphs are going to be like the heart, but then it'll be the sideways heart, or the other way sideways heart, or the upside down heart. So you can take the equation, type it in Desmos. Desmos produces a pretty graph instantaneously, and then just pick the picture that matches. Like, you don't need to know these pictures by heart. All right, end of 5.3.